and welcome back to another StudyingWorks video. In this video, we are going to cover how to design a controlled experiment and how to complete our controlled experiment and understand why we are completing this experiment. There are three main steps to this process. The first one is laying out a plan for how you are going to carry out this experiment. The second part is going to be collecting the data for the experiment. And then the final part is going to be analyzing the data that you have been given to determine a relationship between our variables. So let's get into the video. So for designing the experiment, we have to remember that the whole goal behind designing our controlled experiment is to explain some sort of phenomenon. And to do that, we have to find the relationship between one variable and another. Maybe distance and time, or anything else really. It doesn't matter what we select. But we have to make sure that these independent variables and dependent variables are defined. And we have to make sure that we are assigning a specific variable for them. In math, we're always using y and x, but in physics, we have to have a specific variable for distance, time, and all these different things because they are all different measurements. You can't say that distance and time are the same thing if they're both the independent variable. That's not how it works. So if it's distance, we might have d. If it's time, we might have t, something of that sort. And we have to remember to keep anything else that can affect our experiment constant. And keeping other variables constant doesn't mean we're always thinking about gravity or some other physical constants that are known, like gravity, friction, or anything like that. Those are not the only variables that are affecting our experiment. There can be things ever so simple. For example, if we're rolling a ball on the floor, the surface, the floor that we're rolling it on has to be the same because yes, that is friction, but we have to understand that different types of floors might affect our experiment. So that's specifically what we're keeping constant. And another example could be that the ball we are using is the same because their weights could be different. So those are some variables that we're keeping constant in our experiment. So right here, you can see that I have the second step, which is collecting data. And we need to collect data so that we can identify the relationship between our two variables. I think that's pretty self-explanatory. So in physics, when we collect data, we are not just going to have one data table. First, we'll have the raw data table where we're just collecting data, kind of organizing our thoughts, and then the formal data table, which is where we are going to be kind of keeping that more organized so when I look at it later, I'll be able to understand what's going on. And right here, I have an example formal data table. So with a raw data table, you want to always run multiple trials. And the reason why is because let's say I'm testing a certain distance, for example 1 meter, and I want to find the time it takes for the ball to roll that much. So when I'm doing that, let's say there's some sort of inaccuracy with how I'm timing. If it's really inaccurate, you could consider that an outlier and run another trial. Never erase it. You should never erase data in physics, but you can always run another one. But let's say it's just slightly off. Running multiple trials will allow us to average that value out so it is not as far off from the actual value. And like I said before, you want to use specific variables. Specific variables are really important in physics. And if we look at our formal data table here, one thing you'll notice is the independent variable is on the left and the dependent variable is on the right, and that is called a convention, which is basically a standard that is agreed upon by all scientists. So we're always going to have the independent on the left, dependent on the right. And you can see I've named it, I have put the symbol, and I've put the units because units are essential in physics. And they may not be as important in math, but in physics they are really going to be much more important. And since this is a formal data table, you can see I have average time. So I just need to show how I calculated that from my raw data table. Somewhere at the footer, I just need to show an example calculation. just so I can understand how I got to these values later. The final part of having a controlled experiment is the data analysis. And the first part of data analysis is graphing the data, because understanding the relationship will be so much easier if you can graph the data and see the relationship between the points physically. I know that graphing is really painful, but it's going to be super helpful when you have to identify more difficult relationships. So it is really recommended that you do that. Here on this example graph, you can see I have distance versus time, so dependent versus independent, and I have the context right here. The context is very important. But one thing you'll notice is that wasn't time my dependent variable? Shouldn't I be writing time versus distance? And that is another convention in science, which is that time is always on the horizontal axis when we are graphing, and that is just a convention in science that you are going to encounter a lot, but just don't let that trip you up. Time is still the dependent variable in our case. And you can see right here, I did get a little lazy, but usually you would have distance right here, and you would have time here, and obviously you would have the variable and the units. Never forget to put those. And right here, you can see there's something really strange about how I put my points on the graph. So right here, you can see I have my point, and then I have a circle around it. What does that mean? So those are called point protectors, and really the importance of that is that if I were to draw a line through the point, I would still be able to see the point because I put the circle around it. So it's just easier to see. And now, why is my line not going through all the points? That's because if you remember from algebra, we are drawing the line of best fit, because there is not a specific line that we can draw for all these points. So we have to draw a line that best fits our data, and so that is the white line that I have shown right here. And the next part of this will be creating an equation. And when you create an equation, you do not want to use values that you have in your data table. You want to use values that are on your line of best fit. And that is why I have these little plus signs here. Those are used to signify values that I used for my equation. So obviously for the equation, I'm going to have to find the slope, which is why I have chosen two different points that I'm using on my line to find the slope, and then you can create an equation based on that. And then the final part of this is identifying the relationship. We are going to review so many relationships in physics, and this is really the final part. Identifying the relationship is what we've been trying to get to this entire time, finding out how does this variable affect the other. So that is how we are going to find the relationship based on the equation we have found, and I will review all these different relationships in a different video. Thank you for watching this video. I hope it helps you in your physics class in the future, and I will see you in the next video.